Welcome to Brain Vision.
So we have a diode with a threshold electric field of, we'll say 2.8 kilovolts per centimeter, and it's got an applied field, we'll just call E, of 3.2 kilovolts per centimeter. And the length of the diode is 10 micrometers, so right, 10 to the negative fifth meters, and it's got a doping concentration of, let's see, 2 times 10 to the 2 times 10 to the 14th inverse cubic centimeter, something like that. So let's actually write this. L is 10 micrometers, so 10 to the negative second centimeters. Sorry, 10 to the negative third centimeters. So we want to calculate the electron drift velocity first. So this velocity is just going to be the length times our frequency, the length of our device times our frequency, or the operating frequency, which I forgot to mention is 10 gigahertz. So we'll write it as 10 to the 10th hertz. And so that should just come out to 10 to the 7th centimeters per second. Or we can convert it to 10 to the 5th meters per second, something like that. Part B, we want to calculate the current density, J. So this is just going to be the electron charge times the concentration times the drift velocity. So 1.6 times 10 to the negative 19th coulombs times 2 times 10 to the 14th inverse cubic centimeters times 10 to the 7th centimeters per second. That should come out to about 320 amps per square centimeter. And then part C, we want to calculate the electron mobility. So we can just write this mu as the negative drift velocity divided by this applied electric field. So we'll write negative 10 to the 7th centimeters a second divided by 3.2 kilovolts per centimeter. And so that should come out to, we'll write it as negative 3,100 square centimeters per volt per second.